could die.
Okay.
So obviously we would observe him die because we live in a different dimension in a sense to him. But in his dimension, he would continue to live forever. But it's not a pleasant thing, right? To be, it sounds great at first, but it's like a deal with the devil, because then like you don't really want to live forever, decrepit and unable to do anything.
Yeah, that's a strange thing thinking about life. I was talking about like the concept of heaven with someone the other day, and why I actually think, oh, something like reincarnation could really make sense, because it sounds awesome to go somewhere in the sky for all of eternity after a quick trip here. You know, you do a good job and then you get there and you can fucking eat chocolate and never get fat. You run a 40/40, no problem. You're all around people you love. You drink, you get drunk, and you're never hungover. Like, it sounds amazing.
Yeah.
But it's all good.
Yeah.
And then you don't have, there's no like, maybe you're just totally enlightened at that point, but there's no like struggle. There's nothing to make the good stand out from the bad. So the idea of doing that infinitely is crazy. Similarly, the concept of like living life and knowing I'm never going to die would take away the whole kind of meaning and purpose of like the clock of life here and what you're supposed to try to accomplish while you have whatever time you have. So in some ways it goes against our, you know, little pea-brained ideas in humanity to even understand or be able to appreciate something like that, like not dying, because it takes away from the whole meaning of us living in the first place.
Yeah, I mean, I'm a huge Tolkien nerd. So J.R. Tolkien, who wrote Lord of the Rings, and you know, the elves don't die in that world, right? They just live forever, and it's pretty strange to like compare the way the characters behave in those stories. The elves are just sad like all the time, because they just want the world to be the same, and they hate things changing. Like when the seasons come and the world, you know, the evolution of the mountains and see the rivers change, humans emerge, all this kind of stuff. They hate all that. They just want things to be this, like, just keep it the way I'm used to it. And eventually it becomes like a really kind of tragic existence to have this prolonged life. And eventually, they do kind of go to like a heaven essentially in the story, which is Valar. But the humans have much more impetus about them. They're like, hey, I've only got 100 years. I need to get this shit going. Like, I'm not just going to sit around messing around. I do wonder though, because you know, there's people like what's his name? Brian Johnson. Thank you. Who's trying to extend his life significantly.
You see him take a mushroom trip the other day?
Really?
Yeah. Oh. Yeah, he's trying to live a little bit.
Okay. I'm glad to see him pushing the boat out a little bit on that side. Yeah, that's good for him. I do think it's interesting, like, what would happen if we lived, maybe not forever, but 500 years? How would human perspective change about things like climate change? You know, a lot of folks are like, I don't give a shit about climate change because it's not going to happen for another like 200 years before the world's screwed over. So why should I give a shit about it?
Right.
If we live for 500 years, that's now like poisoning your back garden in your, you know, in your relatively short-term timescale, right? It's like, why would you invest in your retirement fund? It's because, sure, it's a few decades away, but you know you're going to live it. You're going to experience being retired one day. So you want to put some money in your 401k because that's going to happen. So in the same sense, like if you live for 500 years, I wonder if as a society, we might mature a lot and think, you know, I think we're so short-term focused as a society.
That's interesting.
A longer-term view might actually be really beneficial.
Yeah, but you're also talking about like a middle ground there too. It's not like we're going to be immortal for fucking, you know, a million years or something. But, if you lived 500 years, you'd think a little bit more about the timeline in front of you. And I agree, because it's like, especially in America, we think about tomorrow or like today. You look at other cultures around the world, some of them, you know, they think 300 years out or something like that. Obviously, it's more rare these days, but it's like when you're talking about something with the climate and like the health of the planet just in general and like our place in this universe, like that is a human issue. It's everyone around should care. But then you have all these borders and stories basically of countries that are all different and have different opinions and different cultures and different people. So you can't get everyone to agree on something. Yeah. It's like, do you think we can have something? Maybe it's not that, but is there even would it take something like people knowing that fucking aliens exist or something for human beings to suddenly have a moment where we come together and go, oh, wow, we should all care about that because that affects all of us equally, you know?
Yeah. I was talking about this when I was on Joe's podcast as well, because there's like a double-edged nature to humanity, right? That we're competitive and tribal with each other. And that's to a fault in a way, right? Because sometimes being so tribal and wanting the other team to lose is not net good for humanity, right? Wanting to destroy your enemy, especially if it's like in sports or something, we often get like so worked up about wanting to crush your opponent. And that's very human that we feel that way. But if we act that way in society, you're just making other people's experience worse, and those people could go on to do great things. So it's net bad for humanity, I would say. But being competitive also drives us to be better, right? So if you're competing in the Olympics against some super fast swimmer, you're going to train extra hard to try and get to the top of your game. So yeah, I do kind of wonder with alien civilizations, if they don't have that tribalism that we have, that competitivism, maybe they never become technological because they're just not driven to sort of the peaks of what's possible. And if they are competitive and tribal, maybe their fate is to ultimately destroy themselves, because that seems like a distinct possibility, at least for humanity, that we could end up in some kind of giant World War III or something one day. Yeah. So it might be like a double-edged sword, that the only way to become advanced is the same way which ultimately limits your lifetime.
All right, real quick, I got to go to the bathroom. We're going to come back to number 4 and start going through the 3-eye atlas list. I didn't forget, people. We'll be right back. All right, we're back. So we've been, I like the side tangents off this list, because obviously we're explaining 3-eye atlas and everything, but I got a lot of questions about the universe, like all of you out there, I'm sure. But we left off at number 4 right here. We just done number 3, going through a couple of the other ones that have been observed. But number 4 on the 10 anomalies that Avi Loeb had is that the arrival of 3-eye atlas was fine-tuned to bring it within tens of millions of kilometers from Mars, Venus, and Jupiter, and be observable from Earth at a perihelion with a likelihood of 0.005%. So let's go to those hotel notes right there.
Yeah.
What do we got going on?
Yeah, so this one actually is really easy to debunk, because one of my strengths is statistics. I love statistics. I teach that at Columbia, and this is a statistical argument, so we can get into that. So the comet is making a pretty close approach to these 3 planets, Mars, Venus, and Jupiter, but those are not the only planets in the solar system. So if you do the calculation differently, you said, okay, what about how close it's getting to Mercury, the Earth, and Saturn instead? You get basically 50% probability times by 50% times by 50%. So you get 1 in 8. So it just becomes like not a big deal at all that this is the situation. So it really is subject to which planets you pick. So let me give you an example. You could apply this to human beings.
Okay.
So what is the probability I'm an alien, right? So you could look at weird things I'm doing and say, that's a bit anomalous. David does this weird thing. That's a bit anomalous. So I'm going to show off a little bit. But what my best lift, so I think I was the other day, my best lift at the moment is 2 plates for about 5 reps. And apparently...
Pretty good. All right.
Yeah, there you go. Apparently only about 0.5% of the world's population can do that.
Yeah.
Okay, so maybe I'm a super strong alien that's just like hiding in human skin.
You're in the wrong room to be saying that. You're scaring me.
Right, so I know you're probably even more extreme, you guys.
He's
but
like gonna be the fucking Men in Black guy coming.
Could happen. You never know. And then let's say there's a 0.5% probability then that I'm alien by that definition. And now what is it? I also have a weird accent, right? I talk with a British accent. Only about 1% of human beings speak with a British accent.
Makes you sound smarter.
Yeah. So maybe I'm an alien who like couldn't figure out how to talk proper American, and
that's right.
And this is like the best I can do to like pull it off.
Do you have an American accent?
No.
You can't do it.
I can't do it.
I have a shitty British accent, so
okay,
if that makes you feel better.
There we go. I'm not gonna do accents, but if you multiply those 2 probabilities together. 1% being British times by 0.5% of being able to lift 2 plates, then you'd get the same probability hit, 0.005%. So
wow.
It's just all you have to do is just take a couple of things about yourself, like your blood type and like maybe some genetic condition you have or some ailment that you have. Multiply those 2 probabilities together, and you can like trivially get down to this percentage. So if you take the object and just look at its history and say, there must be something about it that's a little bit odd. It's really easy to back engineer like these crazy low probabilities. And again, like if you just take 3 of the planets, you get a much more mundane number than this. So this is just what we would call p-hacking in statistics. P-hacking. So this is a p-value technically. It's not actually a likelihood value in statistics. We say this is a p-value. P-value is when you ask like how surprising something is. So it's a measure of surprisingness. If you engineer these numbers very carefully, it's called hacking, p-hacking, and it's banned in most journals in science to do this. You're not allowed to do it because it's been shown over and over again, especially in nutrition and health. There are so many studies that do p-hacking to say like, hey, if you eat 3 tomatoes a day, you'll get rid of all your cholesterol or something.
Oh yeah, Jesus Christ!
And there's tons of p-hacking going on in those studies. So this is like it's just not legitimately even allowed in most scientific journals anymore. So I think this one's pretty easy to kick out.
I see stuff every day where it's like new study says, and it's like ridiculous thing. And it's like, oh, I guess everyone should just do that now, and you're fucking healed. It's crazy. But if that number, so it's 0.005, if that number had said 0.000000005, you might be like, oh, okay.
It depends on how you do it, because I could just keep adding things onto the, look at lift 225, British, blood type. I don't know, the fact that I'm right-footed. You just keep adding like more and more stuff. My eye prescription's 3.25. So you just keep adding stuff on, and you would end up with ridiculous probabilities. It just depends on how much you engineer it. So a p-value alone isn't meaningful. If you really want it to do something surprising, it's got to do something unnatural. It's not unnatural for an object to pass near to a planet. That's not unnatural. Right. If it came to a full stop, if it just went and just stopped in space, went backwards.
That's not natural.
Then we'd be like, hold on, that is freaking weird. There has to be a ship. I would agree with Avi then. That has to be a ship. Yeah. It is not doing any of that stuff. Everything it's doing is what asteroids and comets do.
Okay. Number 5. Its gas plume contains much more nickel than iron, as found in industrially produced nickel alloys, and a nickel to cyanide ratio that is orders of magnitude larger than that of all known comets, including 2I Borisov, with a likelihood below 1%. All right, let's take that out of Japanese.
Yeah, so it's when you do this spectroscopy of these objects, we talked about the different molecules you can detect coming off it. So we know there's water coming off it, which is obviously very typical of a comet. There's also tons of carbon dioxide and carbon monoxide. Again, totally normal for a comet to do that kind of stuff. And another kind of trace, there's trace metals which come off as well. So there's iron and nickel and other things. And the ratio of nickel to iron is super high. So that's kind of odd. It's producing tons of nickel and hardly any iron at all. So that was the anomaly that Avi's talking about. And that is genuinely quite weird. We haven't really seen any comet. There's no known comet or asteroid which produces this extreme ratio that's been observed for this object. However, we observed it at kind of a weird time. It's pretty rare that we observe comets this far out in the solar system. It's just because this is like the celebrity object. We've been giving it so much attention. So it's possible there's actually a ton of objects we've just not been doing this for that it does this. The other interesting thing is if you look at the papers of these detections, they've been monitoring it all the way from an AU, by the way, is a unit of distance. That's the distance from the Earth to the Sun, 1 AU. We've been monitoring this comet from about 3 AU into about 2 AU and measuring how much nickel it's got all the way along that journey. And what we're seeing is that it started out really extreme and it's getting more and more normal as it gets closer and closer in. And the prediction is actually as it gets closer to the sun, it will be indistinguishable from other comets, the ratio. So again, this kind of speaks to the fact we caught this guy so early that it looks weird to us, but that's maybe just because we don't normally observe things at this part of the journey. And as it's gone closer and closer to the sun, it actually looks indistinguishable in terms of its nickel emission. So it's pretty hard to like really know how anomalous this truly is, because it's the very nature of our observations on it are kind of anomalous. How much attention it's got is anomalous. So the deeper you dig, you get all this extreme, finely grained detail, but it's not obvious whether these things are true for other comets or not. And the other thing is, this is obviously the third interstellar object. So there's only three. There's really only two other objects to compare to, if you're being really honest about it. So to say it's got an extreme nickel compared to solar system objects, but it's not a solar system object. So why are we even like really comparing to that anyway? We know that exoplanets are freaking weird compared to the Earth's, the solar system planets. So why would we expect comets from other star systems to look the same as comets we have here? There's no reason why that should be so.
By the way, you had said this earlier, but it was just coming up in the context of what you were explaining there. When you talk about 3I Atlas entering our solar system, so it's within the same galaxy, but it's coming from a different solar system, which is effectively coming from a different star system. So something, another equivalent of the sun somewhere else. How does that happen? Does it just float in, or is there something that needs to happen for it to be able to leave another solar system and come to ours? I'm thinking like, are there gravitational pulls working against it? What's the science there?
Yeah, I mean, we know there are ways of ejecting stuff out of the solar system even. The solar system most likely probably had a fifth gas giant when it was really young. So there's Jupiter, Saturn, Neptune, Uranus, or Uranus, Neptune, really, in that order. But there was probably another ice giant, so another Neptune-Uranus type object in the solar system. And the reason why we think that is because if you simulate the planets and like let them, orbit around super fast, you speed up the simulation, very often Neptune gets kicked out of the solar system altogether through gravitational interactions with Saturn and Jupiter especially. So the way to solve that problem, because obviously the Neptune's here, is to add another gas giant, and then that guy gets kicked out, and that saves Neptune and Uranus. So we think even in the solar system, we probably ejected not just tiny rocks, but entire planets out the freaking solar system. So there are literally rogue worlds drifting between the stars, which might even have moons, and even maybe there's life on those things. It's pretty wild to think about. So there's definitely ways that can happen. Another good example is Triton around Neptune. So Triton is a moon which goes backwards around Neptune, which is kind of weird.
Yeah, why does it go backwards?
Well, for a long time, people were like, that doesn't make any sense. Like, if it's forming, it should form as the planet forms. It should spin in the same way the planet spins. None of this makes any sense. But then this brilliant astrophysicist, Craig Agnall, came up with a mechanism to explain this. And you basically have two, like a binary object. So you have Triton, and it has another buddy next to it. And these two objects just orbit around each other like a binary. And we know of loads of binaries like this in the asteroid belt. So there's this binary that swings closer and closer towards Neptune. And then what's happening is at the moment of close approach, Triton is on the inside and it's moving at almost the same speed as Neptune. So they're kind of like, it's like two cars down the highway that are moving at 70 miles an hour and 71 miles an hour. You can kind of look through each other's windows and see each other, and it looks kind of slow. And so that means that Neptune can gravitationally capture the moon and grab onto it. Whereas the other object is going the other direction. So that's like the car going the opposite highway direction. Yeah. That's going 70 miles an hour in the other direction. So that's doing like 140. So that thing just gets slingshot super fast and gets kicked out of the solar system altogether. So this mechanism, we think, explains how you can form some of the moons, including Triton. So there are probably these binaries which also kick. So maybe 3I Atlas, maybe Oumuamua used to be in a pair, and they got too close to another planet, and one of them became a moon, and the other guy got chucked out. Yeah, that's a pretty easy way of making these. Yeah.
Right.
We don't know for sure, but that's one easy way of doing it.
When you talk about, I believe you said it was Neptune, when we run these simulations, could be kicked out of the solar system. How long, like, let's say we notice one day, they're getting kicked out, and you can see it's like point of no return. How long does that simulation take for it to actually leave the solar system? Are we talking days, years, hundreds of years?
Millions and millions.
Millions of years.
Yeah. So, I mean, these speeds are very slow. So, I mean, it's going a similar speed to Voyager 1, Voyager 2. And it would take Voyager 1 and Voyager 2, I think, something like 100,000 years or so to reach like the nearest star. So these are very slow speeds, but the galaxy is very old, so there's like plenty of time for these things to make their way.
And then within another thing I was just thinking about, within our solar system, obviously, like, there's planets that we're trying to figure out if at some point we could reach, but they're so far away. Are there definitive cases to be able to say that, not necessarily aliens or something like that, but there's some life on Jupiter, for example? And how do we know that?
It depends what you mean by on Jupiter, because Jupiter doesn't have a surface. So like, what's the on mean? It would probably have to be like hanging out in the clouds, right, just like floating around. And people have speculated about that. Scientists have speculated about that. I think Carl Sagan actually thought about that quite a bit and was, wondering there could be life in the clouds. It's been suggested for Venus, that's true. So a few years back, there was a detection of a molecule called phosphine in the atmosphere of Venus. And on Earth, phosphine is pretty much only made through life, through these, it happens on like bays and shorelines. There's this bacteria. I think it gives that truffle smell. Actually, no, that's DMS. It's like, yeah. So anyway, it's a molecule which is made by bacteria, and it was found in the atmosphere of Venus. And it turns out, even though Venus is like a hellhole, the surface is like 700, 800 Kelvin, so extremely hot. It's like an oven on the surface. So there's definitely no way you'd expect life to be on the surface. But as you go up and up and up, there is a certain layer where the pressure is similar to this room and the temperature is similar to this room. So it's possible there could be bacteria which are just wafting along in the clouds. It's a little bit challenging how they stay up there. Like you need, do they propel themselves somehow, or is there wafts that just sort of keep them afloat for their entire life cycle? I mean, it's a little bit speculative, but in principle, the conditions are right, and phosphine was detected, so people got excited about that. So I think people are, scientists are open-minded about that possibility. It wouldn't be your first bet though, right? Because there's moons like Europa and Enceladus, which have like liquid water underneath their surface and plumes and organic molecules. Yeah. So we know, obviously, on the Earth, the oceans are full of life. So if you've got a giant ocean underneath these moons, it seems like that would be a more obvious place to find life, since we know for sure that's a place where life can survive, rather than saying, hey, the first place we should look is the clouds of Neptune, because you require like two or three miracles for that to work out. Right. Whereas you only require the same thing to have happened on Earth to have happened in these moons. So I think when sometimes the public get frustrated with scientists, like saying, why do you guys only care about, Earth-like planets? And it's not that we're narrow-minded. We don't think about life in strange places, like on the surface of neutron stars. Even people have speculated. Even the galaxy could be a living being. Scientists have speculated about that. The entire galaxy could be an organism.
Being.
Yeah, that is
like the last scene in Men in Black. Basically.
Right. Yeah. So scientists have very wild imaginations. Trust me, about what is possible.
That's good.
But it just wouldn't be. If you're going to prioritize, hey, here's $10 billion NASA's got to look for life. You have to, it's like stocks and bonds. Like, okay, maybe you put like 1% into your Bitcoin or something. I don't know what your portfolio is like, but you're probably going to like put, some of the money in like the high risk stuff, but not all of it. And then most of your money probably lower risk investments. It'd be kind of radical to stick all in like the highest risk thing possible.
You're trying to stick it to what you could relate to. Like a human being, like you said, couldn't live in like a cloud-like atmosphere. They got to live on something that has somewhat similar resources in a way, so that's where you're going to look. It makes sense.
Yeah, and it's similar for stars. It's similar for planets. So yeah, we got to look at least. The chances are good to look at places where we know for sure life was successful.
Yeah, I don't hear nearly as much talk from like Elon and other people these days about the whole colonization of Mars. For years, that was like the thing he would lead with. Always talk about it. Where are we with that? How realistic is that over the next 300 years?
I mean, dude's got $1 trillion now.
That's what I'm saying. It's like, you're telling me about the telescope costing like $10 billion or something. I'm like, buddy, come on.
Yeah, he could easily do that now, right? He's got enough money to do that. I mean, there's a technological challenge, which obviously he's trying to solve with Starship. Starship has had like a bunch of launches. I'm not sure how many they're at now, maybe like half a dozen or so. Each one, they seem to be making progress, but it's been a difficult nut to crack, I think, for SpaceX, as to get that to be a fully reusable vehicle as they imagine it to be. And even if they get that, obviously to go to Mars requires all these extra steps like refueling in space.
How would that work?
So I think the plan is to have like a tanker version of Starship that launches and it's just full of fuel. That thing orbits around the Earth, and then you have another Starship comes up, which is like the crewed version, and then they dock in space, and it dumps all over the fuel to the other guy. And then once it's in space, once it's in orbit of the Earth, it's a little bit less energy now to go to Mars, so it's easier to go. So you can't do it in one shot, I think is true. Like Starship with a crew and all the infrastructure it needs, it can't do it in one shot. You have to have a refueling. So I don't think there's any plans for Starship to test that in the near future, as far as I'm aware. So there's still like a lot of stuff they have to prove. But I mean, I'm in favor of it. I think it'd be great. I really would love to see humans work on Mars in my lifetime. I don't want to do it, but I'd love to see somebody.
It'd be nice to die on Mars, right? You go there. This is where it ends.
I don't know. It's like, would you want to die in Antarctica? Because Antarctica is a lot nicer than Mars.
How so?
Well, Antarctica is it's about roughly the same temperature as Mars. It's not that different in temperature, but it has atmosphere. There's hardly any atmosphere on Mars. It's very, very small atmosphere. So, if you took your helmet off, you definitely suffocate pretty quickly. There's no oxygen to breathe. And then on top of that, there's water. There's tons and tons of water in Antarctica. You just melt the ice and you got water. There's hardly any water on Mars. It's really difficult to come by. There's a little bit in the polar caps, but it's a much more challenging place to survive than Antarctica. So I think that's a good point of comparison. And humans do live in Antarctica, but not all year round. It's like they'll stay there for like 6 months. It's like astronauts on the International Space Station. Like, yeah, you'll do a stint, but
don't sign me up.
No one wants to live that life in Antarctica.
I'm good.
What kind of life is that? So
unless they have pyramids underground, I've heard.
Oh yeah, maybe there's pyramids on Mars. Who knows? I mean, it'd be cool to dig up Mars and see what's going on under the surface as well.
That's a good idea.
Space 2001: Space Odyssey. That's in the moon. They find the monuments, right? So there could be. I mean, I'm actually a big proponent of that. I think I'd like us to do that. I think we should build structures underneath the surface of Mars and the moon for future aliens to find. Yeah,
little reverse engineering here.
Yeah,
from what we're used to.
My pitch is that this is the most likely way that we'll have communication with another civilization, a non-human civilization.
But the pitch is that it'll be after we're gone and dead.
Yeah. So it's not two-way communication. It's one-way. It's the same way that the pyramids are a form of communication, right? There's hieroglyphics written on the surface, and you can decode it, and they're a monument to their brilliance, right? To these pharaohs, and so it is a message which has been sent through time, and we can't reply to that message, but we can learn a lot from that message. So if we're going to have two-way communication with aliens, it requires them to be contemporaneous with us, right? They have to be A, nearby because of the finite speed of light, and B, they have to also happen to have emerged at about the same time that we emerged, and not be so far behind us that they can't use radio, but not so far ahead of us that they don't give a shit about us. So they have, there's a lot of like coincidences you require to have two-way communication. So maybe that'll work out. I'd prefer that, but it might be that one day we come to the realization that's just not going to happen. Like, we've surveyed the nearby planets. There's no one there. The only option we have is to leave a message, to leave a time capsule for someone to discover one day.
Couldn't that be destroyable though too? Like, we always look at New York, and this could all be just completely gone and no recollection that any of this existed, right? So if you're building whether it's a pyramid, whatever it may be, some sort of monument, and your idea is, I think you said, to build it underground or something like that, what's to stop a core event in the event that the planet fucking explodes from destroying all that on the way to rebuilding itself as a new planet? No,
you're exactly right. And that's why I said Mars and the moon especially are not the Earth. The Earth is a terrible place to do this. This is one of the advantages of going to these other planets. The Earth has weathering, right? So if you calculate how long New York City would last for if we went away, it's of order of a few million years, and then there would be a trace of it left at that point. And you see that with like Chernobyl, right? There's, if you look at Chernobyl after that nuclear accident, there's already nature is like taking over. Right. Maybe you can grab some photos of that to show it, but you can see all these like trees and wildlife just kind of encroaching back onto that city. So I don't think there'd be any trace of humanity, whatever we try to do, after say 100 million years.
It's like I Am Legend, basically.
Yeah, exactly. It all just kind of goes away. So the moon, though, is completely different, because the moon doesn't have an atmosphere, it doesn't have rain, it doesn't have wind, doesn't have any geology. There's no earthquakes. There's like very tiny lunar quakes there, but there's no volcanoes. There's nothing to like destroy anything you leave there. And so it's often said that Neil Armstrong's footprints will last there for millions of years. And that's just a footprint in sand.
The footprint will?
Yeah. Just the imprint of his boot will last for millions of years. How long will the Apollo landers last on the moon? We don't even know. We're trying to calculate that in my team right now, actually, with a science project on that. But it will plausibly last until the sun engulfs the moon. The sun will one day get so big it engulfs the Earth and the moon. And that will happen in about 5 billion years. So probably that stuff will be there long, long after we're gone. And an alien, it might stumble across the moon. Because the thing is with the Earth is like a beacon for other aliens. So let's say there's an alien on the other side of the galaxy right now, 100,000 light years away from us. But they could build their own James Webb, maybe a super James Webb, and they will be able to see the Earth, and they'd say, look, we can tell this planet has oxygen. We can tell this planet's got oceans, it's got land, we even probably could tell it's got people on it eventually. But even because of the light time travel effect, they'd be able to, they'd be looking back at basically 100,000 years ago. So maybe they wouldn't see civilization, but they'd still see that we have a rich biosphere. So they would know, here's the galactic map. This guy right here, the Earth, the solar system, there's something special about this guy. There's life on it. There's like stuff happening on this planet. And not just simple life. Oxygen is a sign of complex life. So they would know this is a unique, interesting planet. I mean, this is like a good reason for alien tourism. If you were an alien tourist, the Earth, I think, would stand out as like, this is one of the best places to go in the whole universe.
Why is oxygen in particular viewed that way for complex life?
Yeah, so oxygen is a product of photosynthesis. That's the only way it's made on the Earth, at least. So this is, it took the development of cyanobacteria and plant life to lead to this. So that only happened about 2.5 billion years ago. And before that, for the previous 2 billion years, we just had simple microbial life that was basically living off chemical gradients. And that's like much easier to do from a like internal machinery perspective of life. To develop photosynthesis was a pretty big deal for life. And it took a significant advancement. Once you've got oxygen in the atmosphere, it was possible to have much more metabolism inside cells. So you start to see the development of eukaryote cells, which is really what we are. We are eukaryotes. And that allows for much more efficient energy production once you've got oxygen. So once you've got the energy, you can do more stuff. You can then animals start to develop, and multicellular life starts to develop about 1 billion years ago. So all of that, is likely, we think, conditional upon having an oxygen-rich atmosphere. So that's a good sign that there's something interesting going on here. So I think an alien 100,000 years, 100,000 light years away would look at the Earth 100,000 years ago. They'd be like, something's going on here. Let's send a ship. And it's going to take that ship probably, unless someone has a warp drive or something, it's probably going to take them a damn long time to get over here. We're probably long gone by the time it gets over here. But they would maybe be able to detect something we leave behind. Or maybe this happened 3 billion years ago. Maybe 3 billion years ago they looked at the Earth, and sure, there was no oxygen back then, but they could still see probably there was life on the Earth. They would detect life and be like, hey, maybe in a few billion years, some smart creature might develop on that planet. We're not going to be here in 3 billion years. We're probably going to be dead by then, but let's send something over for those guys. That's the best way for us to communicate. So there might be a time capsule, a beacon, which is really obviously the plot of 2001: Space Odyssey, hidden in our solar system. And the best place to put it would not be the Earth, but would be underneath the surface of the moon, because you'd be protected from micrometeorites. There's no weathering, there's no volcanism. So that would be the perfect place. And there are caves on the moon. These are lava tubes. So when the moon first formed, there was a little bit of volcanism when it was first forming, and it left these caverns as lava flowed underneath the surface. So there's these like cathedral-sized tubes underneath the surface of the moon, which if we seal those off, by the way, that's a perfect place for a moon base, because then you could have atmosphere in these tubes.
Maybe we have.
Maybe someone's done that. Maybe that's what Musk's gonna be doing. I don't know. I'd love to see a moon base do that. And yeah, that's like a super trivial place to put something, because you literally just drive down the hole and dump something there. You don't even have to dig around. And we haven't explored those things at all. So to me, that's very exciting. Like that, if I was thinking logically in our current day and age, what is the best bet for me to if I want to maximize the probability of detection of something for us, that something could be found by an alien species, that's what I would do. If I build a radio beacon, that's a crappy suggestion, because that's only going to last 100 years and it'll break at best, right? It's not going to last that long. So you need something that can not require an active power system, that can somehow be an information-rich beacon in a obvious place that an alien might look.
Yeah, it's like, I was here.
Yeah.
We're gone, but I was here.
Yeah.
Now, they're talking, maybe, I hope I saw this right. I forget who it was, but one of the guys not at NASA, but in the government talking about space exploration was talking about last week, like going back to the moon and how they're planning that and whatever. And when you talk to like all the people who don't believe we went to the moon, I do, to be clear.
But I think like Kardashian doesn't, by the way.
Oh, she doesn't?
She's
She's on that train now?
That's what I read, that she's now a moon truther, I think they call themselves. Yeah.
She went all in. Good.
Yeah.
Well, the one thing, like when they'll bring it up that is quite interesting is the fact that we went in 69 with people and we haven't gone since. What is the logic? Because I would think like the rock that orbits in our system right there, we would want to know everything about that, even if we're not going to like colonize it or something. Like there's resources we can definitely get out of exploring that and being there all the time. Obviously we take pictures of it and scans and everything, so we know stuff, but like why haven't we gone back?
Yeah, I think this is more politics and economics than science, right? So there's lots we can learn about the moon scientifically, but you don't necessarily have to have humans there to learn that. And we keep sending rovers and satellites there. We've been doing that ever since the Apollo era. So we've certainly been sending stuff there, just not human beings. Right. But why politically don't we do it? I think obviously the space race is a big part of it. That's why we went. It wasn't. Yeah, the reason we probably put boots on the moon wasn't for a scientific experiment. That's not what Neil Armstrong was actually there doing.
Say we did it, motherfucker.
He was there. He was there for prestige, right? It was to show off that, hey, we can do this shit and you can't, or we can do it before you. It was flexing. And once we'd flexed and we'd done that a few times, what was the point of staying there? I mean, we'd already established we're the top dog at that point. There was the Soviets had given up on their moon program. They never put a man on the moon the entire time. By the time we'd put like 13, astronauts, walked on the moon. So there was nothing more to prove. And it costs an absolute bomb to do it, right? It's so expensive to fly to the moon with very, very little. Well, there's no economic return really of flying to the moon. You bring back some moon rocks and you can throw those on eBay and try to make enough money, but it's not really paying the bills. So it is a desert, right? So it's very difficult. If we discovered, here's a counter universe and this multidimensional universe stuff. I always love to think about this. Imagine if the moon was just a little bit bigger than it was. It's about 1.25% the mass of the Earth, I believe. So 1% the mass. Now, 1%, it's because it's so low mass, it doesn't have enough gravity to hold onto an atmosphere. That's why it's a vacuum, basically, when you walk on the surface. But if it was, say, 10% the mass of the Earth, which is about the mass of Mars, it would be big enough to hold onto an atmosphere. And so it is and then it's in the habitable zone, right? Now it's a world which has an atmosphere, which is the right distance from the star to have life. And the Earth has water delivered likely from comets, we believe, that comets smashed into the Earth and delivered all the water. The moon would have got that same delivery system, would have had that same Amazon Prime delivery of all that water lying on the surface. And so everything would have been there for it to have had life. And so Neil Armstrong, can you imagine this alternate history? Neil Armstrong sets foot and he doesn't need an astronaut suit. He's setting foot in shorts and a t-shirt and he's still on a beach. And imagine how different the next 60 years of history would have been had the moon had been a habitable world that we could just basically move into right away. Real estate the size of Africa, the landmass about the size of Africa. So it would have totally transformed society. So if that had happened, I'm sure we would have been going back to the moon constantly. But if it's just a dusty desert of moon dust with very little, economic value for us, it just comes down to money. There's any point doing it.
It also feels like when you look over the last 5-6 decades, I'll just speak for this country more than anything, but you could probably say this in different places around the world. The interest for a while there waned in space. It wasn't the same. Like back then it was like, oh my God, we can go to space, that's how it should be in my opinion. I fucking love space. Yeah. But if there's one really positive thing about Elon getting so involved with this in his adult life is that as you've seen him become the celebrity over the last 10, 20 years, him talking about it all the time has people thinking about it a lot more, people interested in it again, which would make sense now with even something like the moon that lacks the resources for you to want to spend the money to even go there. But it's like, if you have more interest and you have more economics from the private side pouring into the space, well, fuck it. You could go to the moon too.
Yeah.
It is fascinating though. when you consider you could have a planet like Mars that maybe down the line you could actually put humans on and they could live there, as opposed to what you said about the moon. Like that's what makes that a little bit more, I don't know, sexy to go look at.
Yeah.
But the moon tunnels, you were saying, like those caverns that they have, you said that was from, there was some sort of volcanic event?
When the moon first formed, it was just a big ball of lava. It slowly cooled down. There was still some active volcanism for a while. But yeah, there's, when you look at the moon, you see there's these light patches and dark patches. Mm-hmm. Maybe throw up a picture. Just photo of the moon. So all those dark patches are lava flows. They're called Maria. So those were ancient lava flows that happened, like 4 billion years ago. And they covered up these cratered regions. There was probably, when the moon first formed, like tons and tons of rocks just smashing into it, like every day. And that's why there's so many craters on the moon. Mm-hmm. The Earth, of course, would have had the same thing, but it's all weathered away by now. But the moon doesn't have that weathering process, so that's why it's covered in craters. But the dark patches are where lava came up from the surface and smothered up over those craters, filled it in. And so, that's a direct evidence that we have that the moon did once have lava flows. And then
it ran out.
From sounding experiments and mapping from these satellites, we can see there's evidence for these lava tubes that are underneath the surface. So they're totally unexplored. What they really look like, we don't really know, but I think it'd be super exciting to go there. I think what's really wild about the moon is that it's like it's a bit like simulation theory kind of stuff, mm-hmm. but it is wild that we have the moon and Mars. It's almost like if you were playing a game in Space Race game or something, you would want to have an object that was close enough that you could do it with 1960s technology. But if the moon wasn't there, we probably would never have bothered developing as much rocketry as we had. The moon is only a 3-day ride with 1960s tech, and you can land and you can do it in 1960s tech. That's kind of crazy. But now to go to the next step, to go to Mars, is much, much harder. But still, it's a rocky planet. Imagine if it was another Jupiter.
Right.
Or another Venus. We can't land on Venus. Venus will crush you immediately the moment we step onto the surface. Mars is like an ideal next stepping stone. If you would like to design a game to try and like nudge the player through a tutorial mode of like, learn how to do this, and then you can do the next thing, and then you can go to the stars, you would put the moon here, and you would put Mars there, and you wouldn't make it too easy. You'd make it challenging enough that maybe like having the moon be truly habitable would just be too easy. So you wouldn't really like push yourself hard enough. So I do kind of think it's wild because the moon is weird. We have the biggest moon in a relative size sense out of any planet in the solar system. It's it's a quarter of the size of the Earth.
Could we like send? I mean, you talk about these unexplored, basically like tunnels in a way. Is there a way for us to put a satellite up there that gets into the atmosphere of the moon, and then, you run some little drones down into those areas and take video?
Yeah.
Or am I thinking that far too simply?
Yeah, I think maybe you can Google like moon lava tube robot, and people have thought about putting like these snake robots that can.
That's what I'm saying. Like, let's do it. Let's go fund this. Like, crowdfund it or something.
Yeah,
I'm in.
Maybe you can't find it, but I've seen these cool visualizations of different robots that we could put down. It is a tricky. Obviously, you can't put a rover down there because it's a pretty steep descent to get into them.
This is China, but
China's doing it. Oh, now we got it.
Yeah, well, different countries obviously have different ideas about exactly how to explore these caves, but someone's going to do it. And maybe there used to be the X Prize, the Google was it Google X Prize, or which was like we'll give you what was it, like $10 million or something for the first person to land on the moon and take a photo. And someone won that prize. Someone landed on the moon, took a photo, and beamed it back to the Earth, and they won this X Prize of maybe it was $100 million. It was a ton of money.
Oh wow!
But maybe we could like get, I don't know, Elon or someone else to say, he's got a ton of money lying around, to say, look, I will give the first person to send photos from the inside of one of these lava tubes $1 billion. Right. And that will spur like a huge bunch of these teams to try and get the investment to develop it.
What is the cooperation like these days among countries, be it NASA and some of the other space programs of other countries? Because we're dealing with something that doesn't have a border. I'm just using the moon as an example right now. Forget Mars even. But like, it's uncharted territory. someone doesn't have to get permission from someone else to go there because no one has like legislative authority over it. So how do we even organize, and what is the organization, I should say, of like trying to figure out some of these space missions these days between countries?
Yeah, I mean, there is a lot of collaboration, but I'm not sure it's going in the right direction at the moment. So you look at James Webb, and it was launched by the Europeans, for instance. So the Americans built it, the Europeans launched it. You look at, and then a lot of that, a lot of telescopes, there is some parts of it are built in Europe or Japan, and they're shipped over, and we put it all together, we assemble it, maybe in the US, and launch it. And there's lots of, Japanese missions which share data with us. There's, again, lots of European collaboration. I think China and Russia, maybe there's less certainly way less scientific collaboration, because there's more, obviously, politically of a tense situation there with those nations. But historically, that wasn't always true. I mean, the International Space Station has had plenty of cosmonauts on board as well as astronauts, and they don't fight. They get on well. Like astronauts.
That's good.
Yeah, everyone gets
no
on.
cops up there. Right. So
there's no one punching each other, as far as we know, in the International Space Station between these nations. So, but I mean, astronauts are picked to be like, that's part of their training, is to be like, you're not gonna pick someone who's an asshole who's gonna fly and be a jerk in the space station, right? You want someone who's pretty easy to get along with to be up there. I mean, so that's a big part.
Picking Matt Damon in Interstellar, basically.
Yeah, right. He's a bit of a jerk. Yeah. You don't want someone with like a really annoying habit to be like up there. I really like making this sound. You don't want that guy with you for the whole time.
So much can go wrong. What was the thing? Maybe this is like one of those things pop in my head. I can't remember if I read it or if it was a joke, but like China was trying to develop something on the dark side of the moon. Am I totally making that up?
No, there's a bunch of, well, yeah, I think China's interested. So China has this giant radio telescope called FAST. We used to have one called Arecibo, but it got destroyed during one of the recent storms. So it's just in pieces now, unfortunately. It's in Puerto Rico, and the NSF, National Science Foundation, supported it, but they didn't have enough money to basically refund it and rebuild it. So we lost it. It used to be the biggest in the world, and then China overtook us and built their own one. But radio telescopes are basically just giant dishes. They can be huge, like hundreds of, I think the FAST is like 500 meters or something across, absolutely gigantic. And the reason why you can build them so big is because they don't have to be very smooth. So unlike James Webb or an optical mirror, it's a piece of glass that's incredibly smooth. It's like has to be smoothed down to like nanometer scale. So it requires lots and lots of polishing, costs a bomb to make those things. And any slight piece of dust or anything is going to ruin it. But a radio telescope, it can basically be made out of concrete, and that's smooth enough to like, you can just pour concrete out. And it turns out some of the craters on the moon are almost the right shape, right? So they kind of look the right shape as a big dish. And so you probably, with a little bit of modification to those things, could use them as natural radio telescopes. And if you put it on the far side of the moon, it would be really advantageous because, one of the problems that alien hunters have, one of the ways we try to look for aliens is to listen for their radio signals. But we just are talking too much ourselves, right? There's all these like 4G, 5G towers going up everywhere. There's, people have got microwaves that they open and send out signals. There's radio channels all over the place, TV channels. So there's just way too much noise to like really clearly hear. So that's one of the big challenges of doing this work. But on the far side of the moon, there's nothing. Right? It's just dead quiet. So it would be like the perfect place to like really listen in and dial in to radio signals from alien civilizations, and also for astrophysics as well.
Can we pull that up, Joe? China, dark side of moon, just to see what, because it just gets so interesting, like you were saying, politically, when you're talking about like superpowers trying to do this. And now America's like, well, we want the dark side of the moon too.
Well, there is no dark side of the moon, by the way. It's far side.
I'm sorry. Yeah. I'm so used to Pink Floyd.
Yeah, that's a common misconception.
So China has successfully completed the Chang'e 6 mission, which returned the first ever samples from the far side of the moon to Earth in June 2024. The mission involved a robotic lander and rover that collected about 2 kilograms of rocks and soil from the South Pole Aitken Basin and delivered them to Inner Mongolia, China. The samples are now being analyzed by scientists to learn more about the moon's history and the differences between its near and far sides.
they grabbed some rocks off the far side and brought them over. Yeah, the reason the Apollo astronauts didn't go to the far side is because for the same reason I just mentioned, you'd lose radio contact with the Earth.
Yeah.
So if something went wrong and they're out there, it's just those two guys by themselves. They're screwed. So all the astronaut missions we've ever launched have always been on the near side, so it's easy to be in constant communication with them.
And you said the moon's approximately 1% the mass of the Earth?
It's about 1% the mass, but about almost 25% the size.
Right. So you're talking about a big space right there.
Yeah, it's huge. The landmass is, I think, about the size of Africa, roughly, is sort of the landmass you've got to work with. So, if you're a real estate developer, there's a lot of stuff to.
They got one of those in the White House right now.
Yeah.
We'll see if he gets any ideas. All right, Joe, let's get back to our list. We're like halfway through it. I like how this is going, just weaving in and out of this thing, coming back to 3i.
Good about side quests.
That's it. I love side quests. I'm from Jersey. It's what we do. All right, number 6, talking about 3i Atlas. This is a part of the 10 ideas Avi Loeb have that makes this different. He says, its gas plume contains only 4% water by mass, a primary constituent of familiar comets.
Yeah, so it's producing water, but maybe not as much water as you'd expect for a comet. But the fact it produces water at all is exactly what comets do. So, what Abby's been sort of suggesting in a big, more zoom out perspective from all of these points is that this is like maybe a Trojan horse, right? So maybe it's like dressed up to look like a comet, but it's actually an alien vehicle that's trying to trick us. And I think you can't really have it both ways, right? Either it's an alien spaceship that's just clearly detectable, or it's pretending to be a comet. But this isn't either of those things, right? Because if it's dressing up to look like a comet, it's not doing a very good job, because otherwise it wouldn't have any anomalies. Yeah. Everything about it would look like a comet. So the fact any of these things are anomalies means it doesn't really match up with the Trojan horse hypothesis at all, because surely aliens, if they're sending spaceships here, would be smart enough to not have 10 things which all give it away as being obviously alien. So what's the game there? So I just don't understand like even the premise of like picking up these individual things. But I think this particular point, it's just like, it's producing water, maybe not quite as much as a typical comet, but that's exactly what comets do. They produce water.
That's the other problem, though. If it were like invading or something like that, that's not, you would think, and everything's a hypothetical because it's really impossible to think the way another advanced, perhaps far more advanced civilization would think and how they even think. But you would think that it wouldn't be dressed up in any way. We wouldn't even know it's there. You would have to, I don't assume is a strong word, but when my mind starts to think about this stuff and you're talking about potentially a civilization that has figured out how to basically like bend time, move at the speed of light, do all these crazy things. If they figured that out, they've probably figured out like invisibility or other things like that, to the point that, when people talk about like seeing UFOs or something like that in our atmosphere, I mean, I don't know. Maybe it's like I've always thought of that like they're simulating that. Like, let's show them one just to see how that idiot will react in the desert and tell everyone about it. So if you were making a 1 kilometer long or whatever it is, like, Trojan horse to come here, it wouldn't be the kind of thing that I would want, like, I don't know, trying to think like them, Avi Loeb to see and go on Joe Rogan and talk about like, hey, they're coming. It's right there. You know what I mean?
Yeah, it's like, the drag queen that can't put makeup on properly. Like, it's like, surely they could figure out a little bit. Like, why is this such a challenge? Like, that's what I don't get at all about this. So, I'm happy to entertain the idea there could be alien spaceships in our solar system. I think it's a really interesting idea. I think we should be looking for them. Yes. So whenever Abby said that, I'm like, I'm with you, brother. Like, we should have programs to look for that stuff. That's cool. But this object everything about it is like not that convincing. But Abby keeps saying, I'm just saying it's a possibility. Like, I'm just saying we should consider this as a possibility. But I mean, that's kind of a slippery slope, because then you could just say, well, what about this? I'm just saying this could be alien. We should everything. You can say it about anything. Should do it.
Yeah, it is.
There you go. It's alien. Right. It's supposed to be alien. So if you just say, well, I'm just saying it could be alien, like, where do you stop? I mean, everything about this looks pretty comet-like. There's plenty of other stuff that you could chuck around the word alien on. So certainly by scientific standards, I get it's a cool and attractive idea and it's jazzy and people are drawn to it, but this is far off the scientific standards of evidence that we would want to have for a genuine alien detection.
You have to think about what the effect is of popularization and how you do it, right? Because, hey, aliens are very interesting. I'm fascinated by it. I look at the size of the known universe and I'm like, it seems impossible that there's not some sort of intelligent civilization out there, wherever that is. But then when you're getting to like the evidence of, oh, have they been here? Are they here? What are they? That's where it gets weird because people, I don't like to shoot everything down, but people make a lot of claims and then you have the government getting involved, which, let's call it what it is. They got a job to do that invites in disinformation on purpose for sure. And people start to run with these narratives that because this, then that, and you're making fucking 40 million leaps when you do that. So when you start talking about things in space that seem to have, we're through like 6 or 7 of these, seem to have some rather viable scientific explanations to point to something different, I think you run the risk of actually setting the seriousness of that conversation back if you just start labeling something alien. It's a lot of fun, but I've enjoyed over the past year talking more with physicists and stuff. Not that Avi Loeb is not a physicist, to be clear, like he is, but I'm saying like I've enjoyed talking with you science guys, if you will, because you look at things based on what is the scientific evidence of what I can see, rather than like in 1964 we saw one in Socorro. It's more like here's how it could happen, or here's what it is, or here's what we're looking at. And that, I think the conversation needs to be more there and then not fall into kind of the trap of like just immediately running to, I see it, so I want to believe it.
Yeah, I don't want us to leave 3 Atlas because it's going to leave the solar system. It's on its way out. And we're going to get many more of these things, right? This is just the 3rd. And we've just built a new telescope called Vera Rubin that's going to detect a ton of these things. So we're going to get like hundreds of these objects in the next like probably decade or so. So this is going to become like normal of having like tons of these objects. And I think people will just stop getting so worked up after it's like number 72 of these things, right? You're just not going to be quite as engaged. And I hope we don't leave it thinking that, the only interest scientists have in these objects is alien or not alien, because this object is a relic from another star system, right? We would love one day, if we could, to send astronauts to a nearby star, land on the ground, just like the Chinese did on the backside of the moon, pick up a rock and bring it home and be like, let's look at this rock. This rock is from a freaking another solar system. Let's look at it. Let's dissect it. Let's see what's going on. Oh, look, their geology is different. Their chemistry is different. Everything's crazy there. These objects are that. If we could intercept them, we could get a ship. One of our own rockets could launch and catch up with these objects. We could land on it. Maybe not a human.
Land on it.
Yeah, we could land on these things. We could scoop up a rock, and just like we did for the moon, and we could bring it back to the Earth, and we could look at them.
Wait, was this the one that was going 60 kilometers a second, and we could land on that?
We could catch up with that. Yeah.
With what?
The best way. Avi was actually suggesting the Juno spacecraft could maybe do it. Juno doesn't have enough fuel, but if it had a bit more fuel, it wouldn't have been able to catch up with it. Juno's around Jupiter, but actually some of the Mars. If you were launching from Mars, it'd be actually pretty easy to catch up with it. If Elon Musk was a few years ahead and we had stuff on Mars already, we could have easily caught up with it. Yeah, this one's pretty fast, but Oumuamua and Borisov could have easily landed on as well if we'd had stuff in space ready to go. So the question is like, you need to have a rocket just hanging out in the solar system, just waiting to turn on its afterburner basically. And then like, okay, there it is. Let's go get it. But we could do it. And then that would be, this is what's so cool about these objects. This would be material that we would have in the laboratory from another star system. There could be simple life buried inside this thing.
Oh,
right?
yeah.
Let's forget like the advanced alien thing. There could be microbes buried inside the core of this little crust, right? So that would be mind-boggling. We'd have there could be DNA traces on this thing. So that's what gets me excited.
Wait, when you say DNA traces, meaning like a trace from an actual advanced civilization?
Well, not necessarily events.
Okay.
Forget the event. Just something living.
Just something living.
Yeah. I mean, we know that happens like if you go to Antarctica, we talked about Antarctica earlier, that's the best place to find rocks from Mars. So Mars gets hit with meteors and it knocks rocks off Mars, and those rocks fly up into space, and some of them hit the Earth. And they hit all over the Earth, but in Antarctica, they're really easy to see because it's all white. So if there's a black rock there, it's like super obvious. So people skidoo around and they find these black rocks, they bring them back, and we can reconstruct where they came from. And a good fraction of them do come from Mars. And we, can study them. And that's how we've learned so much about what Mars is like without even visiting it, is just by aliens. They come to us. We don't have to go to them. And these objects are like that. We don't have, this kind of solves in so many ways the interstellar travel problem. We don't have to go to these other planets. It'd be great if we could, but this is like a shortcut. The universe is giving us a cheat code to see what these other planets are like without actually having to go there. So that to me is like by far like the coolest thing about these objects. Whether it's an alien spaceship or not is obviously a super sensational hypothesis. But even if that's not true, we shouldn't think, oh, who gives a shit about these objects? Of
course.
Like they're still like amazing.
It's amazing. Yeah. That's what I'm saying. Like you put the term on it like alien, and then when it's not, people are like, oh, it goes from 100 to 0. But this is an unbelievable, like you said, potential relic from somewhere else. But so you said they're simulating that it will leave the solar system. Do we have a length of time that'll take for that to happen?
So it's
estimated?
It's behind the sun right now. It's just poking back out, and then it will make its closest approach to the Earth in mid-December. Okay. But it's really far out from the Earth. It's not going to hit us. No way. It's really, really far out.
Thank you guys for checking out this clip. If you haven't already subscribed, please subscribe and hit the like button on this video. It is a huge, huge help. And if you'd like to check out this clip's full podcast episode, that link is in the description below or right here. And finally, you can follow me on Instagram and X by using the links in my description below.